Good afternoon. You're welcome to the tutorials with From Eternity the Schoolboy. Today we'll take a look at chemistry. Today we'll take a look at chemistry. The topic is kinetic theory of matter and gas laws. Kinetic theory of matter and gas laws, part 1. This is our first contact in this topic. Our reference book for today is New School Chemistry for Senior Secondary Schools by Oseyo Ababio, as revised by LES Apanisi and Herbert Igwe, 2016 edition. And we also have unique JAM past question, consolidated past questions from 1978 to 2020, and the Prep 50 chemistry, UTME past questions. So these are our reference books for today. So, as usual, we discuss the kinetic theory of matter. Then after that we round up the lecture with some questions from JAM past with some papers. Alright, so without wasting time, let's move into that. Kinetic, anytime you hear kinetic, what comes to your mind? What comes to your mind? Movement, right? Movements, movement, motion. That's what should come to your mind anytime you hear what? Kinetic. And the matter, of course, chemistry studies what? Matter and changes that matter undergoes. So matter is anything that has weight and occupies what? Space. So now we want to study the movement. How does matter move? You know, we have, when we talk of matter, we have just 3 states of matter. We have the solid, the liquid, and the gaseous state. And we also have the component of what? Matter. Component of what? Or compositions of matter. Where we start seeing things like atoms, ions, and what? Molecules. Then we have types of what? Matter. You start looking at elements, compound, and what? Mixture. Now, with respect to movement that matter undergo, we critically look at the what? The component of matter, which is the atom, ions, and the molecules, is how these atoms come together to form molecules. What is holding them together? Now we have to determine even what holds ions together. Now we have to determine how the molecule, how the matter can move. Am I communicating? The extent of the movement of matter has a lot to do with how the components are arranged, how they are linked up, and how they are held together. Am I communicating? So this determines how they are held together determines which states the matter should be in. Am I communicating? So that's why we are looking at the states of matter. We take it up from there. Looking at what state of matter, we say that matter have 3 physical what? State, at least at this level, okay? Even though we have plasma, but let's focus on here. At this level, we have solid, liquid, gas. We also have plasma, but let us limit ourselves to what your syllables want us to know, okay? Because this is JAM class. Alright, so let's pick these 3 states of matter and discuss them. Then after that, we now talk about the changes they undergo. Now, you cannot understand why I'm talking about these states of matter. You cannot fully understand the kinetic theory of matter without knowing about these states of matter and changes they undergo. If you understand the states of matter and changes they undergo, you'll be able to understand the kinetic theory of matter before you even move on to gas or laws. Now let's look at solid. Solid. What happens to solid? Now, at the molecular level or at the particle level, the particles of solid are held what? Together by what? Forces of what? Cohesion. Am I communicating? They are held what? Together. This is why solid particles, they have definite what? Shape and definite what? Volume. Am I communicating? The particles don't move about. They are in a fixed position. The only thing they can do is that they can vibrate about the fixed what? Position. Are we together? Now, so I said that the solid, of course, we have different solids formed by different chemical what? Bonding. Bonding. We have solid that are ionic. We have solid that are what? Covalent. True of us, and as case may be. Now we have solid that are held where the particles are held together by weak intermolecular forces. Iodine is a solid, right? Iodine is a solid, right? It can exist as what? Solid, right? But what happens? The forces is not as strong to keep it what? Like that. That's why it can easily what? Sublime. Okay, now, so these forces, this force of cohesion holds the what? Particles of solid together. They have definite shape, they have definite volume. They cannot be what? Compressed. Okay, now that is for what? Solid. Now, what of liquid? What happens at the liquid state? Liquid, just like solid, liquid are also held by intermolecular forces, okay? Forces of what? Cohesion. But not as strong as the one we see in what? Solid. Are we together? Not as strong as the one we see in the what? Solid. So they can still move. They can still do what? Move, but not too free. Their movement is what? Restricted. Movement is what? Restricted. Note that their movement is what? Restricted, because they are no longer fixed in a particular, as you see in what? Solid. Now, this is even though liquid, they occupy volume, but they don't have a definite what? Shape. Definite what? Shape. They only take the shape of the container that contains them. Okay? That they just get this inside. The liquid will take the shape of the what? Cylinder. Get a cup. They get this bottle, such as bottle. Pour a liquid inside it. The liquid will be the shape of that what? Of that container. You want to check what if you want to know what I just said now is true or not. Just pour water inside that bottle and they put it in fridge. Okay, bring out the temperature. The temperature solidify, right? You change from liquid to solid. Now use razor blade to tear the plastic container. You see the solid that half of this what? Am I coming? So that's what happens in what? Liquid state. And liquid also is very hard, very important point. Liquid are very hard to what? Compress. Very, very hard to compress. You cannot just compress them like that. The same thing is solid, okay? So it's also difficult to do what? Compress. Are we together? Good. So this is what happens in solid state, and then what happens in what? Liquid state. Now let's go to gaseous state. What happened in gaseous state? What happened in gaseous state? Do you know why? I want to make a very important point now. In gaseous states, the particles have almost have no kinetic energy. Okay? But in liquid, they have the kinetic energy there is at least to some extent, they have the kinetic energy that they can move from place to what place, but they are still restricted. But when it comes to liquid, gas, more kinetic. The particles run only. The only thing that them is the water. The water contains that don't think that can liquid to gas is kinetic energy. Gas is temperature. Apply as heat energy. What? Kinetic energy. Particles will gain it as kinetic energy and start moving out. So you see on the exchange of states. Then liquid, if you keep applying, it's the more kinetic to lead to what gaseous state. So the energy more gaseous what state. The average, do you know why I say you don't kinetic energy? You say the particles don't have the same energy. They differ at average. There will be kinetic energy can move from without kinetic movement, kinetic motion. Okay, so now, the particle about speed. Just state no the container. Okay? Right? Too much if this container is to be true of us liquid. But gas once if you press it, if you put something here that can complete back to them. Altogether. So this has gaseous particles move about randomly. Okay? And the space between them is much. Okay? Okay? So the intermolecular forces of attraction is negligible. Am I communicating? In gaseous state. So that's what they are shape to occupy the entire volume of the water container. Okay? So you can readily compress what? Gas. Gas only restricted the water container. That's why I here and release one bomb from your anus. With time it will get to this end. You know why? The gases, it comes out gas, right? It moves, fill the entire hall. Someone is entering, we know what is going on here. The proper liquid. You put a liquid here. True of us. So that's what happened. So in a summary, that's a table I have here, a summary. It's a table to have a summary of what I'm talking about in gas, liquid, and what in solid, liquid, and gaseous what states. You can draw the table, or you cannot draw a table for a solid, under solid, under liquid, under gas. Fixed mass. Hope you agree with me. What is mass of substance? If you ask the question, what is the mass of a substance? What is mass of a substance? What is a substance? If you ask to find the mass, what is quantifier? Counts as mass. Substance. No. Mass of something is just not the word, the quantity of that make up substance. But weight that weight is equal to energy. Mass time expression of the water. As it's not constant, it changes from location. So because that's so to have it, you wait for sometimes you will change is not mg mass. So if g changes, that means change so substance is not constant. And weight is a force. Newton. Mass is what out of the out of matter. Of what? Basic mass. So they have both the solid, they have fixed. So in terms of their rotation, movement, in terms of movement, we okay, they have fixed mass. In terms of their movement, how do they move? Solids, so they vibrate, okay? And they vibrate and hit around solid particles. Solid particles. They rotate, vibrate, and they position. Liquid particles. Other liquids. Liquid particles. They vibrate. They also, but they move about in a restricted. They stay in a fixed vibration state, but liquid also they restricted basically. What about the gases? Move about constantly are they great to work? Constantly move about. Right? What shape? In terms of shape, how can you describe it? In terms of shape, solid have a fixed what shape. Solid has liquid. There's no shape. There's no fixed shape. Gases have no fixed shape. Solid, liquid has no fixed shape and no fixed shape. What's the volume? In terms of volume, how will we differentiate? In terms of volume, how will we differentiate? In the volume, the solid have volume. Liquid have fixed volume. Solids have fixed volume. Liquid also have fixed volume. Liquid have fixed volume. But gases no fixed volume. As you can see here, right? That is, but they have no fixed, don't fit the entire container. So gases have no fixed volume. What of their how will they appreciate them in terms of what? Compressibility. In terms of compressibility, that's the one that is compressible to compress. For solid is compressible. Solid is compressible. Liquid is incompressible. Gases are what? Compressible. Solids are incompressible. And gases are compressible. What of in terms of that, how we differentiate them in terms of their what? Density. In terms of dense, solid. Liquid are less dense compared to but gases. Least dense. Now we have the three things on that. We also mentioned of matter and how determine how come of matter, they help to determine the state. Let's look at change that on my goals. Let's start change of states. Change of states of change of states. That's what I want to look at now. Okay? So a substance actually can exist as solid, can also exist as what? Liquid. It can also exist as what? Gases. Depending on the what? Change in the what? Temperature. Change in temperature, whether you are heating it or cooling it, can actually lead to change of what? States. Temperature change leads to what? What? States. So you heat a substance now, you are transferring that heat to the what? Substance, and the substance will receive it as what? Kinetic energy. The first it as what? Kinetic energy. And when they gain that kinetic energy, they become so energetic that they will start breaking off from that process of what? Progression. That's what happened. That's what happened. The party will gain more energy and they start breaking away from that what? Interparticle forces. Am I completing? Go together in solid states. Breaking down. When enough energy is more far above the forces holding together, the particles will start breaking off from the what? From the what? Those forces. You see them, the structure will start falling and they will start becoming what? Liquids. Okay? So even in liquids, they still have some level of force, intermolecular force holding. But what happens is that the more heat you apply, the more they break up. At the end, at very high temperature, they will break up entirely and turn to what? Gases. Does it make sense? That's what happened under normal circumstances when some steam, gas, and it will go back to what? This is what happens in what? In what? Change of states. Okay. So let's look at from solid to look at melting. Okay. Let's look at what happens in melt. What happens? So this way solid. What happens? What happens is that they will gain kinetic energy and start violently. And we are structural. At that temperature, substance, okay? Point of the water, solid. At temperature, change to the melting point of the water. How together? Good. And I've also explained what. Let me say it again. What as the solid, position. They are moving. Two of us. That's what you see in liquid. Even though they are moving, that's why you can flow. The solid like that. Also, that's why liquid can flow. The particles together, least, but not that. I see each other and be okay. But for solid, it's not like so. When they now break, they touch liquid. So they are free to move about, but they are still free. So when you say that the solid has melted or liquefied, when you say that the solid has done what? Melted or what? Liquefied. Okay. Now there's something I want to point out. Melting. You can use melting point of a substance to determine purity. Everything. Now. That's what you see. Test purity. You can find a solid is pure. A substance inside. If you have an element sure it's pure outside. So when a substance it melts at particular what temperature. No doubt. But when that substance is not pure, when it has a particular, when it has other impurities, it will not melt. It will melt range of temperature or range. We call it melting range, no longer melting point. Now, melting range for what? Impure substances, solid, right? But melting point is for what? Pure substance. And that melting range, whatever happens there, it will still be less than the melting point. That range will still be less than the melting point of that what? Substance. Once is less than the melting point of that substance, it melts at temperature range and is far below the melting point of the substance. That substance is no longer pure. It has impurities, jam-like this very well. Enough of questions from this statement I just made now. Now, sometimes you see some solids that any small thing, they just break away from the forces. Their intellectual forces is not as strong. Very weak under one forces. Very, very weak that they are not as strong. Solid form. So if there's any small agitation or heat, change the temperature by increase or whatever, they will do what? Break up immediately and move to what? Gaseous states. That's what we call what? Sublimation. That happens in most of the substances where you have weak what? Force holding them together. Out together. Majority of them. So that's what is called what? Sublimation. Are we together? Question here. So let's go to what? Evaporation. So melting transform a solid from a matter from solid to what? Liquid. Sublimation transform a matter from solid to what? To what? Gases. To gas. Now let's look at evaporation. What happens in evaporation? What happens in what? Evaporation. Now, you know, if you have a liquid now, the particles of liquid, there's this attraction. If you have a liquid, there is attraction between the particles of what? Liquid. There's interparticular attraction. You know that one, right? Yes, you know that one now. Because even though they're not as strong as in the case of what? Solid, but there's still interparticular attraction between the particles of what? Liquid. Now, what happens? And you may see a particular liquid. Maybe let's assume that this is a container that contains liquid, right? This is the level of liquid. We have different particles, okay? We have different particles like this of the what? Liquid. This particular particle is attracted in one direction by different particles that surround it, okay? The same way with this one, it's also attracted by different particles surrounding it, okay? The same thing with this one. Okay? So that this interparticulate attraction between the particles of what? Liquid in all directions. Now, what happens? What of the one at the surface? What happens to the one at the surface? This one now, it cannot be. This one at the surface cannot. Is not acted in all directions. What do you know? They are not particularly saying to attract it. Two of us, but it's just this side, and what this side. The one inside the liquid, inside the liquid. They are the surface. Play that this surface. There are no particles here that attract it. Two of us. Good. Now, what is the implication of this? What is the implication of this? What is the implication of this? Who can tell me? Hello? Physics. There's something here I want us to remind us. But what is the implication of this I just explained? I'm listening. Just Huh? Oh yeah, success. No, it's not true. Go to physics. Borrow a word from physics. Very simple word, no. That explains what happened at the surface. Yes. Of liquid. What is it? Is it Brazil? Okay. What? Static force. Static force. Have you ever discussed? Have you ever said that the surface act like a skin? Like a skin. Have you heard of surface tension? Force of attraction. These particles are attracted in ways. Here. It will then be the source of liquid as a type of skin. Okay. That's things like net root. That's how you place a little in a container. It will flow. This thing makes it difficult to do what? Leave the what? Just that have kinetic energy that can break this. Evaporation break up from this. It is a surface phenomenon. You leave this and go. You saw what? Vaporize. Now, I want to point out. Let me ask you a question. Substances like We have done covalent and the covalent substance. Okay, but let me just this is you did it in your secondary school, right? Now, do you know why? Let me ask between electric the liquid form and covalent compound, which one which one is which ones are more volatile? Do you know what? Do you know what are volatile substances? Volatile liquid. Do you know what they are? Volatile liquids. Do you know what they are? Eh? It's not true. You tell me. Say it now. Explode. Not explosion. Not explode. Volatile, volatile liquids. I don't know what you don't know. Wow. So that if you put them in bottle, and you not again. Are you aware? There's some liquid in a container. Just put that in the container and leave it and go. If you come back next day or 2 days, you don't see them in the container. Where did they go?
You don't leave the container with your clothes.
If you people can go. If you come back, you do what? Disappear. They have evaporated. That they are volatile liquids. Even without eating them, just open it and go. If you get your fuel, your petrol, your premium motor speed, your fuel, open it, put it in a container, open it and go. Leave it there for some days. You come back, you will not see it again. They will just do what evaporates. This was called they are what all volatile liquid, and the covalent substances are volatile in nature. Covalent substances are what? Volatile in nature. Listen to me. Covalent substances are what? Liquids are volatile to compare with what? Electrovalent what? Do you know why? If you study your chemical bonding, well, in an electrovalent bond now, the attraction between the molecules are stronger in what? Electrovalent liquids. So the molecules will hold each other, that they don't just escape easily. You know, if they have more kinetic energy, they can evaporate and they can leave the solid and go their way. But in a electrovalent liquid, the attraction is small, that they hold each other, that you rarely see them leaving. Unlike equivalent, like that way that other, you see them, the attraction is not that strong to compare with that of what? That's why the covalent liquids are more what? Volatile. They are more volatile, but they can leave. So that process, they leave this surface called, okay, evaporation. Takes place at all temperature. The increase temperature, increase the rate of evaporation. If temperature, let's look at pressure. That's what go into kinetic what or what okay. Gases, specifically gases. This I've just said about different. This now is nothing but it's kinetic theory of what you know. Before we enter gas, we talk about kinetic law of gases. There's a reason why we want to discuss it specifically before we go into what gas law. All this is we're talking about is kinetic theory of what matter. Now, let's look at vapor pressure. So, what is done by the term? You must tell me this one, or don't tell me you don't know. What is vapor pressure? What is vapor pressure? Tell me now. I'm listening. Don't tell me you don't know. What is is pressure? Huh? It's very what? With what? But no, what is pressure? It's not the pressure. Tell me this one. No. I know agree. You must tell me this one. Let me see that so we can we will discuss it today. Tell me what vapor pressure is. I'm listening. Uh-huh. What are you doing? I am asking what is vapor pressure? I'm listening.
Your pulse at a particular temperature.
Hmm?
Your pulse at a particular
What's that?
temperature.
What is vapor pressure? That's question. I'm not asking you vaporization. Please, vaporization and vapor pressure are not the same thing. I'm asking not only what is vapor pressure. Come share, tell us.
It's the rate at which
Huh?
please,
Say what? Pressure is pressure the pressure is acted by accumulated accumulated vapor of particles that escape from what? From liquid surface. The pressure exerted by the accumulated vapor of the particles that escape from a liquid surface. Let's assume you have a liquid now in a container. Let's assume you have a liquid in a container. This is a container. Let's assume that this is a closed. Let's assume it's a closed, maybe a pot. Okay. Let's assume this is a pot or a closed container. Okay. Are we together? Now, let's assume. Now, this is the liquid inside the what container, and you heat. Okay. Okay. So what happened?
you don't beyond.
Huh?
You can only try and explain.
Go now. That's what I want to hear you explain. Uh-huh. So what are you talking about alone? Uh-huh.
When you are boiling, when you are boiling the liquid,
Mm-hmm.
on the cover of the pot, you will see some particles.
Okay.
So the particle is liquid, and yes, I
Our,
think that's the vapor that is coming out from the liquid.
that one you are seeing in liquid form as well is a condensed vapor.
Okay.
You know condensation is what move when gas vapor move back to what liquid. That one you are seeing in liquid form is a condensed one.
Okay, so you cannot see the other one.
You cannot see vapor with your eyes now. Vapor is the gas now. Can you see gas with your eyes in gaseous state? Unless or liquefied gas, which is liquefied gas is no longer gaseous, it's a liquid, two of us. But I like the courage. At least you say something. Okay.
Is it your boss at this particular temperature. Because
I remember what I said that evaporation takes place at all temperatures. Before a liquid evaporates, you do not necessarily to heat it, okay? But heating it will increase rate of what? Heating it will do what? Increase rate of what? Evaporation. So whether you are heating or not heating is not the issue. The only thing heating can do is that heating will do what? Increase rate of what? Evaporation. Have you noticed that sometimes you put a liquid, water, a liquid, cover it and go. If you come back, you see condensed water on top of the container. On the cover. How did it happen? Did you heat it? It can occur at all temperatures, but what matters is that if you heat it, you are increasing the what? Temperature, and you are increasing the rate of what? Evaporation. Now look up. Look up. Don't focus so much on this. Focus on what's happening here. Now, this is the. Remember what I explained about how liquid particles inside the liquid, they hold each other, right? But they move about. Now, remember what I told you about the surface tension here that prevents escape of what? Particles. Now, you may see something that may have more kinetic energy, higher than that of this surface, this elastic, this stretched scale-like surface that prevent them to go. You may have particles that have more kinetic energy. You can break away from it. Let's say you have many of them, and they break away. And this is as they go, they leave as what? Vapor. They will accumulate at the space above this liquid surface. Okay? They will hit here. They will hit at this cover and accumulate here. If they keep accumulating here, it will get to a point, they will be exerting pressure. The more they accumulate, the more pressure they exert here. So the pressure that these people exert here, both on this wall and the wall here, around this place, this pressure is called what? Vapor pressure. And if this increase, if you get to a point, the liquid will, as they heat, they lose energy and turn into liquid, and they start re-entering the what? The liquid as what? Liquid now. So this is evaporation and this is condensation. Okay? This will taking place as this is evaporating. They are and they are condensing back to the what? Forming liquid and entering the system. This is what will be happening. Okay? Now, if you get to a point where the rate at which this one is happening, you do the same thing with this one is happening. Condensation will become equal to what? Evaporation. At that point, they are equilibrium. In that case, now, what you see that it has reached was saturated with vapor pressure. Okay? When at equilibrium, the vapor saturated at equilibrium when the vapor pressure stops what? And remains what? Constant. And that equilibrium pressure is equal to what? Is equal to what? Condensation. Okay? Am I committing? At that point now, you say that the vapor pressure, we call it a saturated vapor pressure. So the vapor is as what? Saturated vapor pressure. Do you know what? The temperature at which is matter. Okay? This is saturated vapor pressure of the liquid at that particular temperature. At different temperature. Hope you know. Are you aware? Good. This vapor pressure will prepare to what is called boiling point. Boiling. Remember, what is boiling? What is boiling point?
boiling point is
Define boiling point, not that elementary definition. What is boiling point? Okay.
is a particular temperature whereby it depends on the place.
I know. Define it as a scientist. I know. What is boiling point? Define it as a chemist, as a chemistry student. Boiling point is that temperature. The temperature at what they saturate the vapor pressure. Sorry, the vapor is what? Atmospheric pressure. When the vapor pressure of liquid you are heating equals a what? Atmospheric pressure, the prevailing atmospheric pressure, the water will start boiling. And temperature at which this happens is the boiling point of the water of the liquid, as case may be. So with this now explain now about vapor pressure will then take us to boiling. What is boiling? What is boiling? So if you are asked now what is boiling, what are you going to say? What is boiling? Remember that evaporation takes place at temperature. But increase the temperature. If you increase temperature, the evaporation rate will do what? Increase. Okay? But basically, evaporation takes place at all temperature. So now, tell me what is boiling. I'm listening. I give you 1 minute. Boiling.
When a liquid is heated at a particular temperature. When a liquid is heated at a particular temperature, whereby the vapor or is at a particular temperature whereby a liquid is heated at a particular temperature.
Chelsea, you don't say anything here. What is boiling? Or when do we say that a liquid? You have explained this. Who? Are you tired? Me, I'm tired. Yeah, but this let go on. You will not stop. Good afternoon. So, now tell me. I have explained this, so just going to pick the words together and give me what define boiling for me. Simple. What is a liquid is boiling? Simple. That's what I want to hear. Tell me. You with that?
Yes, at a particular temperature.
Let me explain this. Now, and it's rising. This is coming back. This is taking place. Evaporation, condensation. If you get the evaporation, where it will the evaporation is equal to what? Condensation. At this point, you say that the vapor pressure is saturated. It will not rise again. So here now, you saturated vapor pressure. You check that temperature at which the temperature at which you achieve this equilibrium is, can describe it as that the saturated vapor pressure of that substance at that particular temperature. Agree. But when you now apply it, the more you apply it, the more the vapor pressure will keep what? Right? Okay? The more you apply the temperature is rising, I hope you know. Then the temperature will do what? Will keep rising. It will get to where this saturated vapor pressure will become equal to the prevailing atmospheric pressure of that place you are doing the body heating. It will be equal to the prevailing atmospheric pressure. And if it equals to the prevailing atmospheric pressure, the bubbles of the liquid coming out, okay, the liquid will start boiling. Okay, the liquid will start boiling. So a liquid boils when its saturated vapor pressure is equal to the prevailing atmospheric pressure. The liquid will start boiling. Any liquid will boil when its saturated vapor pressure is equal to what? The atmospheric, the what prevailing atmospheric what pressure. Do you know the implication? You can actually reduce the boiling point of a liquid by playing with the atmospheric pressure. If you reduce the atmospheric pressure, the boiling point of liquid what will come down, because the temperature which the temperature, remember, basically the boiling point is defined at the temperature at which is equal to what? Atmospheric pressure. The boiling point of a liquid is defined as the temperature at which the atmospheric equal to what? Atmospheric what? Pressure. That's the point of liquid. If you want to, you can make a liquid to, you can make it boil at a very low temperature. You lower the atmospheric pressure. If you lower the temperature, you at a very low temperature. If you lower the temperature, water at a very low temperature, the saturated vapor pressure of liquid will be equal to what? Atmospheric pressure. So at a very low temperature, the vapor pressure will be what? Atmospheric pressure. You can make a liquid to boil at a temperature higher than its normal boiling point. Work on, you can increase the what? Atmospheric pressure. If you do it, the vapor pressure will be fighting to get to the what? Atmospheric pressure at the temperature is rising. The temperature is rising, the vapor pressure is increasing. So the target is of the vapor pressure is to be equal to the what? Atmospheric pressure. And temperature is increasing. So it will take a very higher temperature for that vapor pressure to meet the what? Atmospheric pressure. That's why it will boil at a very higher temperature, because you have increased the what? Atmospheric what? Pressure. Does it make sense? Does it make sense? So this is how atmospheric pressure, manipulating the atmospheric pressure will make a liquid to boil at a temperature that is boiling point. Does it make sense? Does it make sense? So you ask to define a boiling point. Don't just say is the temperature at which liquid boil. No, try to break it down to what. Any question? Any question? Then also another thing that can increase the boiling point is pressure. So manipulating increase atmospheric pressure, decreasing the atmospheric pressure will increase the boiling point. The presence of it will increase the boiling point of a what? Of a liquid. Please let's note these points. Let's note this. Okay. We have actually, we have best to do. Tire. Why are you bending your head on the floor? Turning normally. Why? Sorry. You not take your CS today.
No, I used to wear glasses.
Huh? Wear glass. So when you wear today?
I don't like wearing it day.
If you are training your eyes to it doesn't get used to it. Okay. Alright, so now I think I have spoken more. Let's see in the next class we talk about what? Freezing and what? Condensing. Let's see what to do from let's see what we can do there so that we can rekindle our listening again on this topic. Let me see any question that has to do with these things we explained today. So we have Let's solve some questions. Okay, one. Yeah. All right, this question is from Jan. The question says, according to the kinetic theory, an increase in temperature causes the kinetic energy of the particle to decrease, B increase, C remain constant, D be zero. This is JAM 2003 question 11 as stated in prep 50. So what's the answer? That's what the answer. Hmm? This is in your notes. I said it now in this class. So you should be good to answer this question. I explained this in this class. So you should answer this question. What is the answer? Pass, what's the answer? Is what? What? I didn't hear you. Huh? You meant what? She said the constant. What's the answer? She says. Check what you put down today. Check your material. Check your notes. Tell me the answer. You must answer this question by yourself. It's a must. I want to answer it. And we are not going to the next one to answer it. According to the kinetic theory, an increase in temperature causes kinetic energy of particles to A decrease, B increase, C remain constant, D be zero. What's the answer? What did I say happens to the molecules of let's particles of a solid together? What does it happen to it when you apply it? When you increase temperature, what did I say? What?
decrease.
Hmm. No, no, no. We just notice now. What is the problem? Check your notes now. Check your notes. Check your notes. Check your notes.
It's increase.
Is what?
Increase.
So where do you get the decrease from?
It's increase.
You said decrease.
But kinetic energy will increase.
You do what?
Particles acquire greater kinetic.
Good. So the answer is what?
Increase.
Which one? It's me now. See. What is your, you know the framework here? Try to marry the two of them. That's what you are doing here. What I just said, no, 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 no. And you put it down. And you put down. Now the button is here now. You're telling me decrease. No, that's the answer is what? Increase. Yes. If you apply it, it will reflect as increase in temperature, true of us.
Yeah.
And this will, that heat you apply will be transformed. Energy is not lost. It can be to convert from one form to the what another. It will transform to kinetic energy, true of us, and they will gain it as kinetic energy. So there will be increase of the kinetic energy of the what particles, and that's when they can break away from the inter what forces. Does it make sense now? So the answer is what? B. Alright, let me look at that question. Another question. Okay, let me write this one here. Hope you are putting these questions down and where they came from. Please. To help you in your revision. Okay? When you are done, so we can answer the question. Can I play this one? Okay. Fast. Are you done? Right now. Okay, let's try a question. The question says, it is difficult to achieve an orderly arrangement of the molecules of a gas because they A can collide with one another in the container, B are too small in size, C have little force of attraction between them, D have no definite shape. This question comes from JAM 2004 question 32 as stated in prep 50. So what's the answer? We explained this today. So what's the answer? What? There is what? Can collide with one another in the container. What's the answer? Which one? D. Have no definite shape. I agree with you. Gases have no definite shape. I agree. Gases can collide, the particles of the gas can collide with one another in the container. I agree. They're also too small in size. I agree. But they're not the reason for why they are difficult to do what? Achieve what? Orderly arrangement. Remember what we said about orderly arrangement? Okay, among solid, liquid, and gas, which of them has which one is most orderly? Why? Because what? Good. They are held together by this attraction. So what else are they missing? You see, they have little force of attraction between them, so they are free. So you cannot easily bring them together to orderly arranged. But that force of attraction has been broken. Have you seen how John said question? These things are actually properties. All of them are properties of gases. But the one that concerns the question is what? So the answer is what? Alright. Let me look for another question. Okay. Well. Alright, look at the question. Look up. Which of the following is a measure of the average kinetic energy of the molecules of a substance? A. Volume. B. Mass. C. Pressure. D. Temperature. JAM 1992 question 7 as stated in Prep 50. So what's the answer? Volume. No, yeah. Do you understand the question? Which of the following is right? By measure mean what I mean average kinetic energy will do what? Increase. Decrease temperature, the average kinetic energy will do what? Decrease. So it's of the kinetic energy. So the answer is what? Temperature. Okay, let's let me know when you are done. Okay, let's look at the question. Here, the question says, which of these properties gives a solid its definite shape? Which of these properties gives a solid its definite shape? A. Weak intermolecular attraction. B. High boiling point. C. High melting point. D. Strong intermolecular attraction. JAM 2005, question 3. What's the answer? Speak up. What's the answer? D. Strong intermolecular attraction. Come see. What's the answer? D. Thank you. The answer is D. Okay. A strong intermolecular attraction that gives the solid is what? Definite what? Shape. Thank you. Now let's see if you can raise another question. We'll do this until 6 p.m. Then we can dismiss. So the answer is what? The strong intermolecular attraction. I'm picking question that has to do with this topic. That's why it's taking me time. Please just okay. Okay. I think I've seen one. Let's look at this one. Are you done? Okay. The question says the process whereby a gaseous body loses some of its kinetic energy to a colder body is referred to as A. Condensation, B. Melting, C. Evaporation, D. Freezing. JAM 2015 question 20. What's the answer? What's the answer? It's what? Condensation. What's the answer? Evaporation. Remember, he's talking about, forget how they tweet the question. Remember, if I am hot now and I come in contact with you, cold body, I'll lose heat to you. And if I lose heat, my temperature will come down. I'll lose energy. True or false? True or false? Then if I am in gaseous state, do you know why? Do you know why if you fill a bottle, a tumbler with cold water or cold drink and keep it on the table and come back, you see water droplets on the body of the bottle. Do you know what causes it? Do you know? Do you know what causes it? Now listen. See what causes it. This atmosphere, this place we are staying now, there are water vapors in the air here now, moisture in the air. And this moisture, they are gases, they are gas, right? They are gaseous form. The water you pour inside that tumbler or bottle is cool, it's at a lower temperature. This vapor in the air, they hit your body normal and go their way because this room you are now see the two of us. That's why they cannot lose good heat. But if you come a bottle containing cold drink or water, see what happens. Once they hit that surface of that bottle, they will lose energy to that what? Cold bottle. And if they lose it, they will drop in temperature and they will change from gas to what? Liquid. Is that liquid you are seeing? The liquid is not from inside the bottle, no. Is it a vapor in the air that hit that bottle? They lost their energy and they changed from gas to what? Liquid. That's what you are seeing on the body of the bottle. And that's what is called what? Condensation. Changing from gas to what? Liquid. So that's why the answer is what? Condensation. See what they say. The process, in fact, they describe what I just described now. They put it in question form. The process whereby a gaseous body, which is that loses some of its kinetic energy when to a colder body. So when you heat that cold drink, it loses energy and becomes what? Water. So it becomes what? Liquid. Is what? Condensation. Is it clear? So the answer is what? Condensation. The answer is what? Condensation. Okay, let me please tell me when it's 6 p.m. Okay? Let me look at this. Let's answer one more question and see how far we can go before 6 p.m. Okay, this one says that this should be the 6th question for today. 6th question says, Chidozie, you are correct. It's condensation. That's good. Nice one. Are we done? All right, let's look at this question. The question says a liquid begins to boil when A, its vapor pressure is equal to the vapor pressure of its solid at the given temperature. B, molecules start escaping from its surface. C, its vapor pressure equals the atmospheric pressure. D, its volume is slightly increased. Jan 1995, question 7. What's the answer? This one is simple. I explained this, I dissected this, so what's the answer? Eh? What's the answer? C. Good. When is the vapor pressure equals the atmospheric pressure? So a liquid begins to boil when its vapor pressure is equals the what? Atmospheric pressure. The answer is what? C. You see, I have like 5 minutes. Let me see if we can answer one more question before it's 6 p.m. Let me look for more questions to for us to answer. Let me see if I answer this one. If we fail this one, I know that. Hey, let's see if I answer this one. Okay. This one says, Right, yes. Let me go from here. Okay, are we done? Okay, this should be our last question for the day. The question says, the droplet of water observed around a bottle of milk taken out of the refrigerator is due to the fact that the A, saturated vapor pressure of the milk is equal to the atmospheric pressure. B, vapor pressure in the air around the bottle loses some of its energy to the bottle. C, water vapor in the air around the bottle gains some energy from the bottle. D, temperature of the milk drops as it loses into the surrounding. 2010 question. Speak out, let me hear. Huh? I described here. B. B. You are sure? You are sure? B. B. I agree with you. I have described. I described this here, right? The answer is B. Water vapor in the air around that bottle. Once they come in, if they hit the bottle, they will lose their what? Energy, changing from gas to what? Liquid, and appears as water droplets on the bottle. So water vapor in the air around the bottle loses some of its energy to the bottle. So the answer is what? B. The answer is what? B. Any question? Any question? So in the absence of any question, we'll stop here for today. Thank you for coming around, and I want to thank our audience, our viewers, especially Chidozie that answered one of the questions. Please, thank you very much for coming around. Share this, follow us on TikTok. For the full lectures, TikTok can only accommodate 10, not more than 10 minutes. For the full lectures, you can follow me on Facebook and YouTube. You see the lectures. My Facebook and YouTube names, the same thing, Farm Eternity, the school board. If you have any question, feel free to chat me up on WhatsApp line on the screen. Thank you very much for your attention and God bless you. See you next time. We'll see when. Thursday, right? Same time, 4 p.m. to 6 p.m. on Thursday. We look at news of English. Thank you very much. Bye bye for now.